Okay, so example 2, my directions state simplify each expression, write your answer without negative exponents. Part A, we've got 3x squared raised to the third power times negative 2x to the negative second. Notice that the first set of parentheses has an exponent on the outside. The second set does not have anything on the outside. So a slightly different strategy as far as how we approach these two pieces. Starting over here on the left, be careful that you do not accidentally apply rules of exponents to a coefficient. Remember, a coefficient is a number that's being multiplied to the base. So we're not going to multiply this 3 with our exponent. We're just going to think of this as 3 to the third power. 3 to the third power, which we could go ahead and calculate if we wanted to. But we're going to do 3 to the third power, and then we're going to do x squared raised to the third power. We know that here we're raising a power to a power, so these we can multiply our exponents. So we've got 3 to the third times x to the sixth. Over here, again, there's no outside exponent to apply. So we're just going to kind of copy it just like it is right now. The negative 2, I'm going to put my negative 2 in parentheses so that I know that it's being multiplied. If I don't put parentheses, it's going to look like we're subtracting it. So all of this is simply being multiplied together. 3 to the third power gives me 27. And then, if I want to, I can rearrange my coefficients and my bases together. So I know 27 times negative 2, I could put those together and multiply those. That would give me negative 54. And then x to the sixth times x to the negative second. I'll do this little squiggly line so it doesn't look like I'm putting fractions in there. X to the sixth times x to the negative second. I'm multiplying like bases, so my rule tells me I want to add my exponents, so it will become x to the positive fourth. And that is my answer. Make sure that's big enough everybody can see it. One thing you'll notice as you're going through these problems, rules for exponents are definitely not the same as order of operations. When you're doing order of operations, it is very important that you do everything in a very systematic order in order to get the correct answer. With these problems, you may do it completely differently than I'm doing it, or completely differently from another person in the class, and still arrive at the same answer, and that's okay for these problems. So don't think that you're doing it incorrectly if you have a different idea from what I'm doing. Okay, for example B, we still have the same directions as before. We're going to simplify and write our answer without negative exponents. This time, the entire fraction is being raised to the same exponent on the outside. So there are different ways that you can approach this. Generally, I tend to just go ahead and apply this outside exponent so that I can eliminate my parentheses. So I know that I need to multiply. I'm doing a power to a power. I want to multiply my exponents. It'll become a, and then that's going to be 5 times 4, so a to the 20th. And then this will be b, multiply negative 1 times 4, so b to the negative 4th. And then in the denominator, I'm going to do a to the 7th raised to the 4th, so that it becomes a to the 28th power. I do not want to leave negative exponents. I also cannot have the same base appearing more than once in my answer. So I've got a to the 20th over a to the 28th. I've got to go ahead and combine these two. I know that I can subtract these exponents. If I subtract these, 20 minus 28 gives me negative 8. Okay? You could put it in the top as a to the negative 8th, but you're still going to have to move it because we're not going to keep negative exponents. So you could also think of it in terms of you've got more a's on the denominator than you have in the numerator, so whatever is left needs to go on the bottom. So we're going to have a to the 8th left in the denominator. B to the negative 4th has to go into the denominator because it's got a negative exponent, so it's going to be b to the positive 4th. All right, so everything has moved out of the numerator. We're just left with a 1 up here. So it's going to be 1 over a to the 8th times b to the 4th for our answer. Okay, so for example 3, we are asked To use the rules of exponents to simplify each expression, write answers without negative exponents. So same type of problem that we've just done. This time, again, you'll notice there are no exponents on the outside of either set of parentheses. So that means you're not applying the power rule this time. All we're going to do is multiply all of this together. So really, in this case, the parentheses are not even needed. So we're going to do, you can just write it with no parentheses, and you can rearrange. So you're going to do negative 5 times 10 is going to be negative 50. X to the 4th times x to the 5th, keep the common base, add the exponents, x to the 9th. Y to the 4th times y to the 7th is going to be y, add 4 and 7, you get 11. And that's it. There are no negative exponents. Yes, there's a negative coefficient, but that's okay because it's not an exponent. There are no bases appearing more than once, so that's our answer. Okay, now it's time for you to try one on your own. Go ahead and try to apply the rules that we've discussed. You're multiplying 1/5 m to the negative 6th into the 3rd times 1/4 m to the 6th into the negative 9th. This is very similar to the previous problem. Of course, you do have fractions here, but these are just coefficients. Just multiply these as regular fractions. If you need to use your calculator, you can do that. Pause the video, give it a try, and then come back and see how you did. Okay, so let's see how you've done. Again, there are no exponents on the outside of the parentheses, so we're just multiplying everything together. 1/5 times 1/4, when you multiply fractions, the rule is to multiply straight across the top, straight across the bottom. So that's going to give you 1/20. Now you want to look for like bases. You've got m to the negative 6th times m to the positive 6th. You're multiplying these like bases, you want to add your exponents. Negative 6 plus 6 is 0. So you've got m to the 0 power. N to the 3rd times n to the negative 9th. You need to keep your common base and add your exponents. So 3 plus negative 9 is negative 6. All right. M to the 0, we've got a rule that tells us that's 1. So you can just think of this as a 1 sitting here. And the n to the negative 6 needs to go into the denominator. So we've got the 20, and n to the 6 goes into the denominator. The only thing left in the numerator is that 1. So this is my answer, 1/20 n to the 6th. All right, so next we're going to be looking at what happens if you're raising a base to a fraction power. Again, you cannot multiply a number by itself, for example, 2/3 times. So there's another way of looking at this. We're going to be dealing here with radicals, working with square roots, cube roots, that sort of thing. The fraction tells me how to set up my radical. The base will go inside my radical. The denominator that I see up here in this exponent is going to be what we call the index. So we're going to put the nth root of our base a, and then the numerator is going to be our new exponent, so a to the m power. Okay? This can also be written if you put the exponent on the outside of the radical. So you could say the nth root of a raised to the m power, like this. They're both correct. Sometimes one is more helpful than the other. Now let's look at example 4. It asks, write the expression in radical notation, simplify if possible. So 2 to the 2/3 power, what does that mean? Again, the denominator that you see is going to be your index when you set up your radical. So we're going to say that this is the cube root of our base 2 raised to the 2nd power. You can put it on the inside or you can put it on the outside. We want to simplify this. We know that 2 squared is 4, so we've got the cube root of 4. All right. The question we have here is, can this be simplified any further? In order for this to be simplified beyond this step, we would need to find a perfect cube inside a 4. Well, a 4 comes from 2 times 2. In order to have a perfect cube, you need a factor being multiplied by itself 3 times. For example, if we had an 8 in here, we could simplify it because it would be 2 times 2 times 2. 4 is just 2 times 2, so we cannot take the cube root of 4 without getting a decimal approximation, and we are more interested in the exact value. So we're going to keep the cube root of 4 as our fully simplified answer. Part B, we want to do the quantity 3x raised to the 3/4 power. So we'll go ahead and draw a radical. Okay, what is the index going to be this time? This number comes from this denominator. So I need to put 4 for my index. We've got the 4th root of 3x. All right, you can put the exponent 3 on the outside of your radical, or you can put the 3x in parentheses and put it to the 3rd power. You need these parentheses to indicate that both the 3 and the x are being raised to the 3rd power. Now, is this simplified? Well, we can take this a step further. 3 to the 3rd, that will be 3 times 3 is 9, 9 times 3 is 27. So we've got the 4th root of 27, x to the 3rd power. Is there anything that can be taken out of that radical? Again, I would need a factor that's being multiplied by itself 4 times, and I do not have that. If I had, say, x to the 5th power, then I could simplify it a little bit, but with x to the 3rd, I can't. And this is, of course, 3 to the 3rd. Nothing comes out there either. So this is our fully simplified answer, 4th root of 27, x to the 3rd. Just like we had a product rule and quotient rule for our exponents, we also have the same rules for radicals. These rules simply state that if you're doing the nth root of a product, that you can break this apart as the nth root of the first factor times the nth root of the second factor. If you've got a fraction inside a radical, you can break this apart as the nth root of your numerator divided by the nth root of your denominator. So example 5, we're being asked to simplify the radical expression. We're going to be using the product and the quotient rules for radicals to help us with this. The first one, we can break this apart as the square root of 3 over the square root of 16x squared. Okay. And there's nothing I can do to simplify the square root of 3. But in the denominator, I can simplify this radical because I have perfect squares inside. I know that the square root of 16 is 4, and the square root of x squared is x. So we've got the square root of 3 over 4x. And that is our answer for this one. For part B, we can break this apart as the square root of 49 times the square root of x squared times the square root of y. The square root of 49 we know is 7. The square root of x squared would be x. Y is not a perfect square. There's nothing I can do to take the y out of the radical, so it's going to stay inside. So we've got 7x square root y. Okay, so it's time for you to try another one. You're going to simplify the expression. This is quantity x to the 8th, y to the 4th, all over z to the 20th. This is all being raised to the 1/4 power. So go ahead and pause the video, see what you can do, and then check your answer in a moment. Okay, so how did that one seem to you? It shouldn't have seemed, it shouldn't have been too involved. You're raising a power to a power for each of these individual bases. So you're going to be multiplying your exponents. This is going to give you x, and you're going to 8 times 1/4 is going to give you 2. So x to the 2nd, y to the 1st over z2, and then 20 times 1/4 is going to give you 5. And there is nothing more that needs to be done to simplify this one because there are no negative exponents. There are also no repeated bases. So we're good. This is our answer. X squared times y all over z to the 5th.